Hi everyone, I'd like to walk you through my process for C++ development in VS Code. Basically, if I were doing an X280 project, what would be all the steps that I would work through? This will mirror pretty closely some of what's in our setup tutorial. And additionally, there's a lot of really great documentation for VS Code online. And in particular, you can find specific documentation for if you're doing C++ development, everything from making sure you've got your C++ extension installed, that you get IntelliSense support so that you've got the red squiggles underneath compilation errors, to making sure that your debugger is set up and ready to go. You don't have to necessarily look at the online documentation. The X280 setup tutorial contains basically everything you need for this class, but there is some more cool stuff here. So I'm going to start out by pretending that I am just beginning project 2. And so I'm going to go ahead and go find the project spec for project 2. And we're going to first get the starter files. So let me get to the wget command that we need for the starter files. So that's right here. And basically, just to recap, wget is a terminal command that retrieves a file from the internet and downloads it to your current directory. So let's go ahead and do that. Let me just close out of this so that I don't get notifications while I'm recording this. And we're going to download at the terminal. But first, I'm actually going to create a new directory. So let me just go ahead and make a directory in here called project 2. I'm going to go into that directory, and then I'm going to go ahead and open up VS Code and work from there, even before getting the starter files. So the way that I open VS Code is I just go to my terminal and I type code dot, which is going to open VS Code in my current directory. Dot at the terminal always means my current directory, whatever that happens to be. And this will open up VS Code, and it's important to do it from your terminal. Hello, terminal. There we go, it's just taking a moment. It's important to do it from your terminal because that's going to ensure that you are opening up VS Code through remote mode so that it's working in Ubuntu. If you open it from the Windows side, like let's say I just went down here to the icon and I selected to open a new instance of VS Code, you'll notice that it doesn't have the Ubuntu up here, which is going to mean that compatibility with C++ is a bit trickier. So it's best to go ahead and launch it from the terminal. Now, in order for that to work, you should have the WSL remote extension installed. That's one that we mention in our setup tutorial. If you don't have that, you can just go ahead and search for it and then install it. Speaking of extensions, the other one that you're going to want to have is the C++ extension. That ensures that you get the like autocomplete when you're working in VS Code, that it has compilation support, and so on. So you can check the status of both of those by going to this button down here with the blocks being put into place. That's your extensions. Then you can always pop back up to here for your file explorer. Of course, I don't have any files. I just made this new P2 folder. So let's go ahead and get some. And the way to do that is with the wget command. And I could go back to the terminal that I've already got open here. But it turns out that VS Code can open an integrated terminal. And I often find that more convenient than having to jump out to a separate terminal. Let's get rid of this extension stuff here. And then I'm just going to go to Terminal and New Terminal. You can also get to it by pressing the Control key and then the tilde. That's a shortcut, or you can go to the menu. Either way is fine. And then we'll pop open a terminal here. It'll be situated in the same folder as VS Code. Now, something that actually is pretty convenient is that you can open VS Code from a terminal when you already have a terminal in the right directory. But what if we don't already have one that's in the right place? What if I just wanted to open up some, I don't know, let's go to this random folder here. What if I wanted to open up VS Code in this AutoGrader tests folder? I could open up a terminal and then do CD a bunch of times to change directories into here, but actually there's a nice trick on Windows. You can just click into this white area where it shows your file path and then type bash. Bash is the name of the terminal program. And if I hit enter, it's going to open up a terminal, and this obnoxious blue color is hard to read. That's hard to read too, but I'll assure you here, if I do pwd, you can see that I'm in my AutoGrader test directory where I was with my file explorer. So if you ever need to open up a terminal in the same directory that you're looking at via File Explorer, just go in here, type bash, hit enter. It'll open up the terminal, and then you could also launch VS Code in that same location by just doing code dot. All right, so that was a nice little aside. Let's go back to VS Code and finally get our starter files for project 2. So I'm gonna copy this wget command here, go ahead and paste it into the terminal. In the VS Code terminal, you can paste either by doing Ctrl V, that'll work. In your normal terminal, sometimes Ctrl V won't work, and you can do right click instead. All right, we'll run this, get our starter files, there they are. Let's go ahead and extract them as well. If you're like me, you'll find this tar command really hard to memorize. Except someone, my younger brother actually told me to remember it as tar, and then it's xvzf. So his way of remembering it is X is for extract very quickly Z files. So I don't know if that helps you, but that helps me remember what it is. You can also, of course, just go look online or look in our setup tutorial for what command you want. So that's going to move my starter files into this folder. I can use the VS Code interface to just grab and select some of these files. If you click and then shift click, it'll select a range, or you can control click to select a bunch of them. And the goal would be to move them outside of the starter files folder. But it's actually going to be faster to do that from the terminal. So I'm going to use the move command, move starter files /star to my current directory. That's going to move all of those up here. And then let me just go ahead and delete that starter files folder, which I don't need anymore. So I've now got all my project 2 code in here. And there's a few things to go over in terms of basic navigation through files in VS Code. If you single click on a file, it's going to open up that file in a temporary editor. And then if you click on a different file, it'll just open that file. It won't stack them up and create a bunch of new tabs. If you want a tab to be persistent, then double click on that file. And then the next time you click on something else, you'll retain that original file in its own tab. If I go ahead and open up a whole bunch of these, then I can accumulate a bunch of tabs here. And I also have a list of all of my open editors that I'm working with right now. So if you have an intermediate number of files open, let me see if I can do this. Did that? Yeah, I just opened a whole bunch of them now. So you can scroll through your tabs up here using a mouse wheel or whatever, but it's often easier to find them in your open editors here. There's also some nice shortcuts, like you can close all editors if you just want to clear out your workspace. Another neat thing you can do is if you've clicked into your File Explorer or your Project Explorer here, and you start typing the name of a file, like let's say I wanted to find the Makefile. I can just start typing Makefile, and it's going to go ahead and jump to any files which match that pattern. Let me hit backspace to get rid of those. Let's say I wanted to find like the 70 by 35. Type that in. It's going to filter down to only the one that I'm looking for. And in fact, if you type something that's not visible, it'll scroll you down. Oh, I don't have a resize yet. I haven't created that. Let's say I wanted to go find the unit test framework. It scrolled me down automatically to unit tests. All right, so that's, I think, everything I wanted to say in terms of navigating through files. Let's get into a few pragmatics for project 2. How do we compile and run our code? So first, we don't really have a lot of code yet because we haven't started working on the project. Like if I go to my matrix.cpp starter, I've got assert falses for all of these functions. They don't do anything in particular. I can run the matrix public tests though. This is one of the tests we provide you. So I'm going to go ahead and compile this one, and we can run it from the integrated terminal in VS Code. One thing to know about VS Code that's different from many other IDEs, different from Xcode and Visual Studio, which we also recommend that students might use in 280, is that With VS Code, you're not compiling through VS Code itself. You're compiling separately via the terminal, and then VS Code, even for things like debugging, where you're using the VS Code interface, it's essentially latching on to the executable files that you've just created through the terminal. That's different from Xcode or Visual Studio, where you're actually compiling with a compiler that ships integrated with those development environments. And that's neither good nor bad only. It's just different. Visual Studio Code is in some ways a more lightweight development environment in that it doesn't come with all the bells and whistles, but it's still quite powerful and, of course, certainly better than doing your coding in Notepad or Microsoft Word or whatever. But there are some differences, and we're going to be using the terminal a bit more and relying on specifically the Makefile that we provide you for each of the projects. So I'll give you a very brief introduction to Makefiles as well, because I think it's especially relevant if you're working through VS Code. We could compile let's see, we were going to do matrix public tests by typing out the G++ command, so I could try to remember, okay, I think I need a WALL and WError and -- standard equals C++11, and then for matrix public tests I need matrix.cpp and I need matrix public tests, or just test.cpp. Then I want my executable file to be called matrix public test.exe. That's behind my head in the video, so you can't see that. Let me go ahead and adjust. How am I going to adjust this so I make sure that you can see what's going on? There we go. All right. So most of my commands won't be this long. Let's pretend you can see that. And okay, I goofed up on actually, I don't think I goofed up on compilation. I just forgot to rename these files. So let me go ahead and rename my matrix CPP starter. The reason that we have the starter on there is so that if you try to extract the starter files again, you wouldn't accidentally overwrite a matrix.cpp that you'd been working on. So I'm going to manually rename that. Let's try to recompile. And wow, it actually compiled, so I can run my matrix public test.exe from the terminal here. G++ is your compile / whatever you called it to run the program. Of course, this fails immediately because we've only got assert false in our code, and that just crashes. This is one way that I can compile up my code and get it to work. Let me remove that matrix public test.exe file, and we'll look at how to do the same thing with the Makefile. There, essentially, I just have to type make matrix public test. And by the way, I've been doing this, but I haven't mentioned it. If you notice, wow, I'm typing these really fast. Like when I do matrix underscore, and then it just randomly appears. I'm hitting the tab key to do autocomplete. So this is one of the super valuable tricks of working with the terminal. If you've got part of something typed out, part of a command or part of a file name, in many cases, if you hit tab, it's going to autocomplete to the only thing available that matches. Well, let's say I just typed matrix. If I hit tab, it's going to autocomplete the underscore. Apparently there's things that start with matrix underscore, but because there's multiple, it didn't fill it in all the way. If I hit tab twice in quick succession, it's going to show me a list of suggestions of things that might autocomplete. This is useful if you're just, trying to type something in and you kind of forget what a file is fully called, then you can see all your options here. So let me type in enough to distinguish it, matrix, and then hit tab, and there we go, make matrix public test.exe. And what this is going to do is run a pre-made compile command that's encoded into our Makefile file. So make is a program that's going to look for a file called Makefile, and it's basically got a sequence of targets. So these things in the yellow font here are all my different make targets. So I could type make test, make matrix public test.exe, make blah blah blah, whatever, and it's going to run whatever command is on the next line. Now this command looks like a bunch of nonsense. This doesn't look like what came out down here when I ran it. But the way it works is that these are, these $ parentheses are variables. so that cxx is our variable that stores the name of our compiler. cxx flags stores all the flags or options that we want to provide to the compiler, so those get plugged in down here. This $ up arrow means all of the dependencies that are listed here. More on that in just a second, but these are basically the source files, and the $ up arrow is going to go up here and get them. And then my -O and the $@ means the name of the target, which was the name of matrixpublictest.exe. Now, the inner workings of Makefiles are not something that we consider to be a core part of the EX280 curriculum. It's sort of incidental stuff that gets lumped in with tools that are useful for you when you're programming things that we provide for you on the project, but you shouldn't expect some detailed question about the syntax of Makefiles to show up on an exam or anything like that. So when I run make matrixpublictest.exe, it's going to go find this and it's going to run it. Now if I write that again, it's actually going to tell me, hey, it's up to date. I didn't need to do anything. And the way the Makefile keeps track of that is by looking at these dependencies listed here, and only if one of those files has changed is it going to remake the matrixpublictest.exe. And that kind of makes sense. If we don't change any of these files, we don't need to recompile. This is not super important for the 280 projects, which are relatively small in scope compared to some production system that has tens or hundreds of thousands of lines of code that might take a really long time to recompile. And so mostly the dependencies are useful when you have large projects where you really don't want to recompile if you don't have to. If you feel like your Makefile is misbehaving and it's not recompiling when it should, you can always do a make clean. There's a clean target that you can find down at the bottom of the Makefile. It basically just removes all of the files that the Makefile would produce. So you can run that, and then the next time you run a make target, it's guaranteed pretty much that it's going to fully recompile. So that all said, now we can use the Makefile to make various targets that are useful for project 2. If you want to run matrix public tests, you got that. If you want to, in fact, run all of your tests, this test target, if you just do make test, that's basically going to run the AutoGrader's public tests on your own computer. All of the public tests on the AutoGrader are things that we've provided for you with the project starter files, and make test is configured to run all of those for you. Okay, so I think that's enough on the Makefile. If we wanted to run our program then, let's go ahead and make a main program. So the main program on project 2 is called resize. So I'm going to create resize.cpp, and I'm not actually going to implement anything related to project 2, for one, because I don't want to give it away, but also that would take longer than I want to spend on the specifics of the program. So here I'm just going to make a main program that doesn't do anything particularly special. Let's make it a little bit special. Let's go ahead and add a string in here for the person's name, customize it for me, and then we're going to print out hello and then the name. Okay, go ahead and do make resize.exe. Oh, and the Makefile is configured to require image.cpp. So let me go ahead and pretend for now that we're not actually going to use the Makefile, and let me just go ahead and do manual compilation with G++. So minimally, we're going to need the -G, and then we're going to need, I won't call this resize anymore. Let's call this hello.cpp. Okay, that's compiled. Of course, I can run it from the terminal here. If I wanted to add command line arguments into this, then I can add in my argc and argv. And then in here, let's say instead of hard coding the name, we're going to make it the first real argument. Remember that the name of the program is argument 0, so I want argument 1 if I'm going to do anything meaningful. I need to make sure to recompile. and then I'm going to do ./hello.exe, and then we'll put in here Cameron, and then it's going to print that out. If we want to use command line arguments or run the program with the VS Code debugger rather than just from the terminal, we need to configure those things in a file that VS Code uses to determine how it should launch your program when it's going to run it through the debugger. We can't just launch it from the terminal, although behind the scenes it's kind of using a separate terminal. You could sort of think of it that way. And to get the debugger going, we can go to this run and debug here. And then if you haven't done this before for a particular project, it's going to prompt you to create a launch.json file. You can pick any of these you want. I'm going to go ahead and pick this top one for GDB or LLDB. GDB you'll have if you're working on Windows or Linux. LLDB is the equivalent if you're working on a Mac. And by the way, my apologies if you're working on a Mac. Since I don't have a Mac, a few details of like using the terminal for one, or of getting VS Code installed, or like the remote extension for Ubuntu. Those will be a bit different on a Mac. Ultimately, they should be simpler, but they will be different. And then it really doesn't matter what we choose here. I just wanted to get that launch.json file. And now I'm going to replace it with the suggested version from our setup tutorial. So if you were to go back to eeks280.org and then go to tutorials, you could go through the mega tutorial, but there's a quick link to the VS Code section here. And then in setup, there's a section on how to run, and then there's a standard launch.json. You can find one for Mac, one for Windows, one for Cygwin. Avoid Cygwin if you can, and WSL is way superior if you're on Windows. Let's go ahead and copy that whole thing, delete everything in this file, and then paste it in. There's a couple different things that you'll want to pay attention to in order to tell VS Code which program you want it to run. So first of all, there's CWD and program, which have this variable in here for workspace folder. You want to leave that. That'll just ensure that wherever your VS Code is sitting, that's going to be where the debugger starts as well in terms of a working directory. And then we got stats test.exe. That's from project 1. We don't want that. We want to do, in my example, hello.exe. Okay, then let me go ahead and go back to my hello.cpp, and I'm going to set a breakpoint. Let's just put it right here. And then I can go ahead and launch my debugger. But before I launch my debugger, one thing that's important to remember, and I guarantee that you'll probably forget this at some point because I forget it all the time, and I almost did just now, because VS Code is not doing the compilation, if you debug, it's not like VS Code is automatically going to recompile and rebuild everything before debugging. It's just going to go ahead and try to debug what you have in terms of your source code and also your compiled file. So by the way, it switched me over to debug console. I don't want that now, so I'm going to switch back to terminal. And you can actually see that it's tried to launch some different terminal for debugging. So I can just press any key as it said, and it'll take me back to my old terminal. Now, I'd previously compiled hello.cpp here. Let's say I add a bunch more lines. I put in, some random variables and everything else. And I've got a breakpoint, and to set this breakpoint, I just clicked here to the left of these numbers. I've got a breakpoint in my source code on line 10, but because I haven't recompiled yet, line 10 in the executable file that I have is actually the line 10 from before I made these changes. If I debug now, my debugger is going to appear to stop on some random line where I didn't have a breakpoint. And if you see that, that probably just means you need to recompile and relaunch your debugger. So let me go ahead and do that. I'm going to recompile. Oops, that's not compiling. Recompile here. By the way, another terminal thing, hit up to get your most recent commands, hit up more times to go farther back in your history, hit down to go back forward in your history until you find what you want. Okay, recompiled. Now I think I'm ready to launch the debugger. So if I was like in Project Explorer or somewhere else, I just click back into this debug menu here. and then I can click the green arrow up here at the top, and that's going to run whichever program was specified in my launch.json file. All right, so let's go ahead and run it. And in theory, it should stop on the line where I had set the breakpoint. So good, this worked. Now there are a few different things that you can check out while you're paused in the debugger. First, I should mention that the debugger always pauses just before executing the line that's highlighted or where you set the breakpoint. So here it hasn't actually initialized name yet. And that's actually why if we look at our local variables over here, it's not showing name because I haven't set name to anything. It's telling me, oh, I can't access memory address 2. So apparently the string was originally containing some memory junk, and only after I go past this line is it going to contain the value for my arguments. I could try to go past it, but a problem here is that I didn't actually specify any arguments. I just clicked this green triangle button, and I didn't tell it what name I needed to go in for argv1. So that's something else that we're going to have to specify in launch.json. Let me go ahead and get out of here. And we'll go back to our setup tutorial, and there's a section in here for arguments and options. What we want to do in here, it gives you some examples which are actually similar to project 2 and project 5. And it tells you that in order to use command line arguments that would look like this, we have to add this args portion to our launch.json. So let me go to my launch.json, and you'll notice that there is an args here. It's currently empty. Let's just go ahead and put in the name that we want here. So let's do Sally. And then I don't have to recompile because I didn't change my source code. I am in this weird funky terminal for the debugger. If you ever want to get rid of the terminals, you can just click this trash can and it'll take you back to your bash. If you accidentally click that too many times, just go ahead and launch the terminal again, and it's not going to hurt anything. All right, so I provided this argument. Now let's go ahead and launch it again. It's going to pause on the same breakpoint I had before. Still, name is not initialized because I haven't run this line yet, so I'm going to click step over, which is basically your simplest option to just go down one line in your source code. So I'll do that. And now name has been initialized properly to Sally. I can also see, argc, argv, I could open it up and poke around a bit if I wanted to. Argv is going to give me some sort of kind of interesting results. Like I can look at and see there's my argv0, which would be the name of the program. It's got the full path there that was used to get to it. I don't know why this is, this is dereferencing argv twice, which would get me to the slash character that's at the beginning of that. Now, because argv is just a pointer, the debugger is not really smart enough to figure out that it was a pointer into an array and find me the Sally that I'd be looking for. If I want, though, I can click over into the debug console here, and I can run some limited number of commands to poke around at my program. So I believe if I just do print like argc here, maybe this doesn't work with VS Code. I haven't actually tried this. Interesting. Oh, it says execute debugger commands using exec command. So let's try that. Thank you, VS Code. Exec print argc. There we go. Prints out argc. So if I wanted to, I could do -exec print. Print is just a GDB debugger command that will give me the value of a variable that's like in my current local scope. So I could print argv of 1, that's going to give me Sally. Or if I did like print argv1 of 2, that's going to give me the L that would be at index 2 in that C string. So in addition to just looking at your local variables listed here, you can also poke around at things through the debug console. I'm not sure how much use this is going to be to you, but it's available there if you want to try it. Okay, Let me write up a slightly more complex program in here so that we can try some more things. I clicked that red square, by the way, just to exit my debugger. And let me get rid of this just because I like seeing my terminal. And I'll write a function. So let's go ahead and make some function that's going to take in a parameter, and then maybe I'll take in something by pointer as well. While I'm at it, let me initialize these variables. And then, I don't know, let's just return some value. So y equals x plus star pointer, and then let's return x plus y. And then maybe I'll do one more thing, which is create an array. Cool. And we'll call a function. And maybe we'll pass in x, and then we'll pass in argv index 3. And then, oops, not argv, that my array was what I wanted to use. So maybe I'll just rearrange this so it's a bit clearer. And then why is this complaining? Because I didn't mean to do that. I meant to do this. Yeah, because I want a pointer to that third element, not the actual third element, to match up with my pointer type here. Okay, so then let's see out, see out z. And we got to remember to first save the file. This little dot up here, that tells me the file hasn't been saved yet. So I'll hit Ctrl S, save it, and then we'll recompile. I could hit up a bunch of times to try to find my G++ command. Oops, it was actually there. But another trick is to do a reverse search at your terminal. If you hit Ctrl R, and then it'll bring up this reverse search thing. You can just start typing part of a command. So I just typed G++, and it brings back the most recent command that matches some part of that. So then I'll hit Enter to run that. We've recompiled. Let me set a couple breakpoints here, and we'll go ahead and run my debugger. All right, so we've got more stuff over here in the locals. You'll notice that X and Y and Z now show up. Previously, when I did this, I had X and Y in there. They weren't showing up because I suspect the compiler just optimized them out because I hadn't used them at all. Now they're being used, so they have entries here. X and Y and Z, in fact, all of X, Y, and Z have junk values because I haven't gotten down to their initialization lines yet. So let's step past some of these. We'll just click this a few times and we'll get to those. Now we should be able to open up array, look at its values. Everything has meaningful values except for Z here, which is yet to be computed. If I were to click step over, I would just go all the way past this line and I wouldn't go into the function. To go into function calls, you have to click step into instead. So let's do that. That's going to take us to this function. I'm on my first line right now. I haven't actually initialized X and Y yet. I can step over to do that. Now, I guess I didn't mean X and Y, I mean X and pointer. Those are now initialized. Pointer, we can also open up and we can see its address and we can see the dereferenced value. What does it point to? And that's kind of weird. I have some junk value there. So you may have caught that I snuck a mistake into the main program earlier, but let's say that we weren't sure why this was happening. Like, why is pointer pointing to junk? We don't really have enough context from within function to figure that out. So one thing we can do while we're paused in the debugger is check out the call stack down here, and we can see all of the different stack frames for functions that have been called. So func is my most recently called function, and it was called from main. I can click here, and then I can go back to main, and it's going to show me, first of all, now it's showing the variables in the stack frame for main. It's also showing me the line in main from which func was called. So that's highlighted as well. And here I can start to assess the problem. The problem's actually a little bit weird. Let's go back to func for a second. I've got this -8704. If I go to main, That's kind of close to what's in Z, but it's not the same as Z, so that's sort of weird. Let's look at how this was computed. And in fact, I believe now that I'm back in the context of main, if I went to my debug console, let's try this, see if it works. I could do dash exec print, and then let's just print like R sub 3. Hey, there's that 8704 that I'm getting. So that kind of makes sense. I passed in R plus 3, which is a pointer. When I dereference it, I get that junk value. The problem is that this value itself is actually 1 unit past the end of the array. I probably meant to do R plus 2 if I wanted the third element because it's 0 indexed, but I messed that up. And going back to main where you have the context to see what was actually originally passed in is really helpful when you're debugging. If you get way down into a function like func here and you're like, I don't know why this is wrong, sometimes it really helps to pop back out and get more context. Let me explain the rest of the debugger controls that are here. Well, first of all, there's restart, which restarts the program. That one's pretty self-explanatory. There's step out, which is kind of similar to step in, but opposite. It's going to, instead of going into a function, it's going to immediately leave the function. And what I mean is it'll just like run the rest of the function until you get back out. So if I clicked step out here, it's going to go over these lines of code and jump me back out to where I came from. And then I can continue stepping forward. Let me also restart. And then the last one here is continue. This is basically going to continue running the program until the next breakpoint, if there is one. So let's say I was investigating the behavior of this function here, and I wanted to run my program and then just stop whenever func is called. I could do that, and then I can click continue. And you can, of course, edit your breakpoints, just like I'm doing now, while the program is running in the debugger, so that maybe you set a breakpoint here at the beginning, and then you look at something and you figure out, okay, the next place I care about is go into here, and then you can just continue and run until there. Sometimes that's going to be a lot faster than spamming the step over button to step down to where you want to go, especially if you need to like get past a loop or something that runs a lot of times. Okay, so that's some of the basics of using the debugger in VS Code. There are other things that will be helpful to you. Let me show you one, which is if I have something that causes a crash, so we're going to pass in a null pointer, then it's going to get dereferenced here, then VS Code is generally going to be able to point out the line where that problem occurred. I might have to eat my words here. It looks like it is not. Let me try setting a breakpoint. That's weird. Oh, I didn't recompile. Look, I did it. Just what I said I would do. All right, now if we run it after we've recompiled, then it crashes with a segmentation fault and VS Code tells you, hey, here's the line where that happened. That's usually pretty helpful because now we know it's not necessarily this line that is problematic. This line is fine, but it's something having to do with this pointer that is problematic. And in fact, when it crashed, we can see the values of the variables even after the crash and say, oh, hey, it's definitely because the pointer was null. And we could even jump back out to main and be like, okay, well, what in here caused that pointer to end up being null? So I definitely encourage you to get familiar with your debugger because for common issues that come up, it's really a tool for getting you more information about what's going wrong with your program. So if you have some hypothesis that, all right, well, I wasn't getting the right result from func, but I don't know if that's because func is broken or if it's because the stuff that's getting passed in originally from where I call it is bad. Then you could just set a breakpoint at the beginning of the function, run the program, check things out at the beginning of the function. If x and pointer are wrong, then that tells you that the problem isn't with func and it's somewhere else. So the debugger is a tool for getting more information so that you can narrow down what you think might be going wrong with your program. Let me just check my notes for a moment and make sure that I haven't skipped anything important. Yeah, so there are a few things that I think are going to be really helpful to you. Let me go back to my project 2 files, and I think I can showcase a few examples there better than with this simple hello program. So let's go ahead and go into our image starter. Let me rename this. Actually, I'm going to rename all of them. And I'm going to take a brief detour while I'm doing this to say that there are a lot of really cool text manipulation tricks in VS Code and other editors, but I think VS Code does this particularly well, that will make some tasks that would otherwise take a while take not very long at all. So here's my current task. I want to rename all of these files that are named .starter to remove the .starter, and I don't want to have to do it one at a time. Let me use the terminal first to get a list of files. So I can do ls, it's going to give me that. I can go ahead and use output redirection to take the output of ls and put it into a file. So that's what this symbol here means. You can actually use that when you're testing your code as well. The tutorials on our website and project specifications often refer to like running a program. Let me take another detour while I'm doing this. Let me clear out all of that. Back when I ran /hello. Oh, my segfault is still in there. Let me fix that. Get rid of all this stuff. One thing that I should mention as well is, like, what if I just wanted to comment out all of these lines of code? You can press Ctrl/, and that'll put comments on all of those. So let's go ahead and do that in case I wanted to get those back later. Save it, recompile with our G++ command, run ./hello.exe. Did I not recompile? Oh, I need arguments. There we go. Let's say instead of printing that output to the terminal, I wanted to store it into a file. I've noticed also that the sun is setting and my face is illuminated. Let me fix that. All right, so we want to take the output from this command and put it into a file instead. So let's put it into a file called temp. And then I'm going to go ahead and find that. Here's temp. And hey, look, there's the hello, James. So this turns out to be really useful if you wanted to take the output from your program and say compare it against the correct output. Let me fake something real quick and say that for your overall project 2 program, oh, the sun is setting again. Sorry about this. There, hopefully that will fix it. Let's say you were running the overall program and you were looking at, say, one of these correct files, like this one, which has the output that you're supposed to get when you run the overall program. And you discovered that your output was slightly different. You could store your output into a temp file. And let's say the difference was something sneaky, like, I don't know, maybe this was a 255 instead of a 0. And you wanted to compare temp against the correct. You could kind of switch back and forth between them and try to see what was wrong. You can even drag these tabs and put editors side by side in VS Code if you want. But another thing that you can do that's going to be better than just looking at it with your own 2 eyes is select both of these files, right click, and you can choose compare selected. And then it's going to show you a difference visualization of what the actual differences are between those files. So you can find diff checkers online. You can run a diff program from the terminal. You can also do it through VS Code, and I think the interface is a lot nicer here than what you might get otherwise. So let's start unwinding all of these deviations that I went on. I was going to list all my files and find the starter ones. So I can do ls. I could also do ls and then send the output to temp and then go into temp. And there's a lot of really cool tools in VS Code for text manipulation. So I can do, and I'm not going to tell you how to do this in terms of all the shortcuts, because I think that would take too much time. I'll have to do another demo sometime about all of these text manipulation tips and tricks, but you can highlight part of the code. There's a shortcut to find and select the next occurrence of that. So I'm going to hit that a bunch of times until I've got them all. Now I've actually got a bunch of different cursors here. You can see them moving around together. And I can use those to select that starter portion if I want. Then there's also a shortcut that will select the entire line that your cursor is on. So I can do that. Let me go ahead and then copy those lines, select everything, delete everything, paste the lines I copied. Now I've got the names of only the starter files. I can go ahead and select those again, select the .starter part, select everything before the .starter part, copy those, use multiple cursors to put move commands in here, then move my cursors to the end of the line, paste the part that didn't have the .starter, and now I've got a bunch of move commands that are going to rename all my starter files to the equivalent without starter, and I can go ahead and copy that into my terminal. And now, if you were watching closely, you would have seen all those files rename themselves. So this is just an aside to say that there's a lot of really cool tricks you can learn to edit files more efficiently that will save you a bit of time, and they also look really cool. So sometime in the future, I'll have to do a demo session on all of those tips and tricks as well. Let's get rid of this for now. Let's go ahead and remove that temp file. And then what were we doing? I was going to show you some more complex stuff in terms of what VS Code can give you along the lines of C++ support. So let's say within image init, I decide that I need to do something with a matrix. This code does not represent anything that you should necessarily be doing on your project. I'm just using it as a place to write some stuff. Let's get rid of that assert false. And let's say I want to use a function on that matrix. So then I might use, let's say, matrix at. You can note that I started typing, and VS Code is automatically auto-completing things that might be relevant and that are to some degree at least legal in C++. So I can pick the one I want. I can also, in VS Code, this is kind of cool. If you know that there's a long function name or something, you can start typing the first letters of each piece of it. So if I want matrix column of min, value, and row, I could type M, C, O, F, M, and it's going to match parts of the names. I don't know if you'd want to do that or not, but you can. So let's go ahead and do matrix at. Then I'm going to put in, first let's put in X, and let's say we want to get something from X at position 3, 5. So first of all, VS Code will give error squiggles if there are any compiler issues. Here it's saying that there's no instance of matrix at that matches a matrix int and int. That's because matrix at wanted a matrix pointer rather than just a matrix here. But how can I know that without I remember it because I've seen this project before. You can hover over and then hold down the Control key, and names of functions will turn into links. One thing is if you hover over it, it'll actually show you a preview. And within this preview, there's the signature of matrix at where it was declared. So actually, that's all I would need to do in this case. I can see that it takes in a matrix pointer. If I wanted to actually go where this was defined, I can Control click on it, and it's going to jump me to the place where that was defined. Okay, so let's say I've looked at this. I say, aha, it's a pointer. Now I want to go back to where I was previously. In VS Code, you can do Alt and then the left or right keys to navigate forward and back, much like you would in a web browser. So if I do Alt left, that's going to take me back to image init, the last place where I had clicked my cursor. If I did Alt right, it's going to take me forward, and I can alternate back and forth between those. So that's another useful thing for navigating around so that you're not scrolling back and forth through your code all day trying to find different pieces. The Control click is also something you can do from a menu. So if I right click here, then I can go to, what am I looking for? Go to definition. That's the equivalent there. You can also do interesting things like, for example, let's say I was at the definition of matrix at, right click, go to find all references. It's going to give me a list of everywhere that anything refers to matrix at. So matrix test helpers, for example, apparently that's got calls to matrix at. The one that I just added in image.cpp is up here. So this is really useful if you're trying to navigate larger projects and figure out what the connections between different pieces are. One last thing, I believe this is the last C++ related trick. Let's say you've got a variable and it's used a bunch of places. For lack of anything better, let me just copy this a bunch of times. And let's say I decided X was not the best variable name. I can right click it and go to rename symbol and then rename it to something better. And it's going to automatically rename that variable everywhere. That same thing works for functions as well. Don't do this because you're not allowed to change the function names that we give you, but you could rename image init to be something else if you wanted. And it's going to change it here and it's going to change it everywhere else. Sometimes VS Code gets a little bit nervous when it's not sure that it's doing exactly the right thing, and it might show you a preview down here of all the places it's planning on changing image init. You can approve or reject some of those in different places. You can kind of poke around and see what these buttons say when you hover over them. Let me just cancel that because I don't really want to do it. All right, one last thing. If you want to make the editor feel more like it's yours, you can choose a color theme. So let me go ahead and go to, I'll give you one more shortcut and also how to get to it from the menus. Ctrl-Shift-P, at least on Windows, brings up the command palette. You can also go to View and then Command Palette. And that will let you basically search through all the different commands you might want to use in VS Code. So I'm going to search for color, and it's going to give me an option for color theme. So click there, and then it'll give me a selection of a bunch of different color themes. So if you want, you can play around this and choose from a variety of different options. You got some dark options, there's some light options. I prefer the dark ones because I feel like it's easier on the eyes, but you go with whatever you like. Let me switch back to mine. And in fact, you can even, I think you can search the web for additional ones that people have created and go all out with customizing the individual colors and things like that. All right, so I think that's everything that I've got time for now. Please don't hesitate to come see us in office hours if you want to talk about more tips and tricks, post on Piazza, or just chat with others that you know in the course. Share cool things that you learn as well. In fact, that's the way that I've learned a lot of these tips and tricks, is by talking with other people and seeing the cool things that they've discovered. So I'll see you next time.